Okay, the next one we want to calculate is about the difference between the estimated value and the mean of the dependent variable. So if we look at this figure, so we have the regression line and we have the mean value of y. So here what we want to calculate is the difference between the y hat and the y bar. And if we do the summation over the difference squared, is called sum of squares due to the regression. So here is called SSR, so for short is SSR. So there's a relationship between the three terms we just talked about. So the relationship between those three is SST is equal to SSR plus SSE. So SST is the total sum of squares, and we have sum of squares due to regression and sum of squares due to error. So that's the relationship. And how do we use this relationship? And how do we show the fitness of the regression model to the data? On this slide, we are going to talk about the R squared, or it's called the coefficient of determination. So the R squared is the ratio between the sum of squares due to regression and the total sum of squares. Okay, so SSR, SST, if we look at the name, we will know what they mean, and this is R squared. So that's why when we do the regression model, so if we go back here, so we have this R squared. Okay. So this tells us the goodness of fit for the estimated regression model. So the ratio is called, you can call it R squared. So normally I call it R squared, but the English name is the coefficient of determination. Okay. So how can we explain this R squared? So that's the percentage of the total sum of squares that can be explained by using the regression model, can be explained by the model. So that's R squared. So how do we do this R squared? We already added that, we kind of already did that by getting the R squared in the figure. Okay. So the next model is called multiple regression model. So the previous one is a simple linear regression model. We are already done with that model. In that model, we only have one independent variable. That means we assume that the dependent variable, or the y variable, only depends on one factor or one variable. In our case, that the only factor is miles traveled. The miles traveled. Okay. But in the multiple regression model, we have more than one independent variables. Still, we have the y variable or the dependent variable, but we have x1, x2, to sq. So it really depends on how many variables or factors you have. So the the beta 0, beta 1, beta 2 to beta q, those are the parameters. So just like the simple linear regression model. So it's just that we have more variables and we have more parameters here, and we also have the error term. So that's for the population. And similar to the simple linear regression model, we need to use data to estimate those parameters. So if we do that, it's called multiple regression analysis. So this model tells us what's the expected value of y, or the mean of y value given a set of the independent variables. And to estimate those parameters, we use B0, B1 to BQ because those are our sample statistics. We use those values to estimate the beta 0 through beta q. So the b's are the point estimators of the betas. Okay, and the y hat, we still have the y hat because that's the estimated value, or the estimated y value. So similar to simple linear regression model, we also use the least squares method to estimate the bits, the bits b0 through bq. So why do we do this simply multiple regression model if we have a simple linear regression model? So we will explain that in just 1 minute. So still we use this method to estimate the values. The objective is to minimize the summation over the difference squared. Okay, so that's the same story. And the process is also similar. We want to formulate this model. We want to estimate the parameters of this multiple regression model. So we collect data. Okay, here is our data. We have y data observed, y value, we have the x values, and then we use those data and use the least squares method to estimate the parameters b0, b1, and so on and so forth. And then we will have a estimated regression model as the estimates of the parameters in this model. So that's we will have a similar process. So the question comes back, why do we do this multiple regression model if we have the simple linear regression model? So if we look at the same example, the Butler's example, so we have r squared is equal to 0.66. That means only about 66% of the y values or the miles values are explained using the simple linear regression model. So 66% of the variance explained by the model is not bad, but it's not good. That means still 33% of the variance is still not explained. So why is that? Maybe we need to introduce more factors because the travel time may depend on more variables, not just the miles traveled. So then we will try to add more variables in this regression analysis. So that makes us to do this multiple regression model. Then let's add one more variable. So we assume that the number of deliverers can also affect the travel time in addition to the miles traveled. Okay, so right now in this regression model we have two variables, or I'm sorry, two independent variables. One is miles traveled, the other one is a new one, which is the number of deliveries. So all the terms, the sum of squares and those three terms and r squares can be computed or calculated using the same formulas we discussed in the simple linear regression model. Okay. So how do we do the multiple regression model in Excel? So let's use a new file which is called, let me get the new file here, it's called Butler with deliveries. They collected more data. So this is the new Excel file. We have more data. So how many assignments we have? We have 300 assignments. We have the miles, we have the times, and one more column is called deliveries, number of deliveries. So we have some more data. So now let's perform a multiple regression analysis. So let's click on the data and go to this data analysis. Okay. So if you have that, let's find the regression. Where is the regression? Okay, here is the regression. Let's click on it and OK. Now let's select our y data. Y data, still we want to predict the travel time. Let's select the time. Okay, so that's the time. And x range. So we have, because we have two variables right now, or I'm sorry, two independent variables right now it's miles and deliveries. Let's select both columns. Okay. And then let's check these labels, because the first row is labels and confidence level. Let's put 99%, and that's okay. New worksheet. Okay, that's the default option. So let's just go with that and click OK. Now we get the output. Okay. So here we have the intercept, which is B0. We have the miles, and we have the deliveries. Let me just keep 4 decimal places. So those are the coefficients that we need. The intercept, miles. So that's, if we go back, so we already did those. Okay, so where is the model? Okay, here's the model. So if we go there, so B1 is the slope, the parameter of x1, so that's miles traveled. So the B1 is equal to 0.0672, and B2, this is B2 deliveries. So we got all the parameters here. So right now we have the regression model. Okay, so here are some snapshots of doing the regression analysis. Okay, here is a sample output. And if we plot the regression model in a 3D plot, right now, because we have 3 variables, 2 x variables and one y variables, so we have to use 3D plots. So miles, number of deliveries, and the vertical axis shows the travel time. So this surface is the function, the regression model that we just created. Okay? And if we choose a pair of x values, say 3 deliveries and 75 miles, then we can have an estimated travel time, which is the y7 hat, and we have a corresponding observed y value, or the real y value, which is plotted here, and we can also calculate the residual and so on and so forth. Okay. And then let's go back to the Excel file. And in this Excel file, we have more information. We have R squared, standard error, and if we look at this table, we have standard error, t-statistic p-value lower 95%, upper, and so on and so forth. Whoa, what do those numbers mean? So we will talk about those numbers in the next class. And this is what we have for today's class. So in this class, we talk about simple linear regression and multiple regression. So I will open a summation folder. We are going to so those are the 2 Excel files we worked on. So let's submit both files in the folder. Okay. So let's keep those 2 files, because we are going to use those 2 files in the next class.